Good afternoon, everybody. Today we shall go with the Lami's theorem. We shall go with the Lami's theorem. What do you can you anybody state the Lami's theorem? If three concurrent coplanar forces, how many forces there are? Three. Concurrent means concurrent entry. Ion of action of all the forces meeting at a single point. If three concurrent coplanar means all the forces were lying in a single plane. If three concurrent coplanar forces either pushing the joint. Okay, good afternoon everybody. Now we shall go with the Lami's theorem, the application of this particular Lami's theorem. We basically know the basic definition of this particular Lami's theorem. What is the statement of this particular Lami's theorem? If three concurrent coplanar forces, either pulling a joint or pushing a joint are in equilibrium, then each force is proportional to the sine of angle between the other two. Is it right? Now totally how many forces there should be? Three forces. 2 with through, you can't apply the Lami's theorem. 4 with through, you can't apply the Lami's theorem. That is the limitation of this particular Lami's theorem. And the application we shall see. Okay, totally there should be three forces. Okay. Now this is the force A or F1. This is the force F2. And this is the force F3. And A, B and C is the angle between the two forces. A, B and C is the angle between the two forces. Is it right? Now you can observe that there are three forces. Correct? The line of action of both these forces are meeting at a point. They are concurrent force system. They are lying in a single plane. Therefore it is coplanar. Okay? Three forces, okay, which are concurrent and coplanar. And the line of action of all the three forces are meeting at a single point. Okay, then it is in equilibrium. When it say it is in equilibrium, what is the resultant of these three forces? See, the resultant of these three forces will be equal to 0. That's what the term equilibrium means. Are in equilibrium, then what it says? Force F1 divided by the angle between the other two forces. The sine of the angle between the other two forces is sine C. Then F2 divided by the sine of the opposite angle between the other two forces is sine B, which is nothing but equal to the force F3 divided by sine of the opposite angle between the other two forces is sine B. Which means that if at all while solving the problem for equilibrium of connected bodies, we have studied if one of the force and all the other angles are known, then by using this Lami's theorem, you can find out the other two forces. Andre, one force ಗೊತ್ತಿದ್ದು ಎಲ್ಲ angle ಗೊತ್ತಿದೆ. If you know all the other angles, you can find out these two forces, the other two forces, F2 and F3, by applying this particular Lami's theorem. Okay, now that we shall demonstrate here for that particular Lami's theorem. Okay, but okay, anyway we know the statement and we know the application. Now we shall check by experimentally. Okay, anyway, these are the two pulleys, frictionless pulleys, at the end of which you applied these particular forces. We know that whenever a string and the load that is applied at the end, since it is passing through the frictionless pulley, whatever the load that you are going to apply, it will be transmitted to this particular string. For this particular one, whatever the load you are going to apply, that will be transmitted to this particular string. Now say, we have the two forces. Say, wait, table meeting. At some particular point, we are going to apply some particular force F1. Okay. At this particular point, we have applied the force say F2. We applied some particular force say F2. Now, for these particular two forces, R will be the resultant. Is that right? For these two forces, F1 and F2, R is the resultant. How we are going to get the value of R? R is equal to root of F1 square plus F2 square under root, or by using the parallelogram law, we are going to find out the value of the resultant. Correct? Now, when R comes into picture, is it in a state of equilibrium? No. Two forces are there. For these two forces, for F1 and F2, R is the resultant of these two forces. By applying the parallelogram law, how we are going to get the value of resultant? R is equal to P square plus Q square plus 2PQ cos theta. That is, if you call this as a P and this is the form, say call it as a Q, P square plus Q square plus 2 times of cos theta, 3 times of thing, but the inclination between those two forces. In that we are going to find out the value of the resultant. P square plus Q square plus 2 PQ cos theta gives you the matter of the resultant. Since R is not equal to 0, the system is not in equilibrium. The equilibrium is air forces illa. Now, for this particular system which is not in equilibrium, you are going to apply a third force. You are going to apply a force C. When you apply this particular force C opposite to the resultant, this we call it as equilibriant. What is equilibriant? Equilibriant is the force which brings back the system to equilibrium. But equilibrium now we have added this particular force. Now when you add this particular force, the whole system is going to be in a state of equilibrium, which means that the resultant will be equal to 0. Now the whole system is in equilibrium. Now we can say that totally how many forces are there? P, Q and C. There are 3 forces, and you can observe that all the 3 forces are acting away from the joint. This forces is pulling, this particular force is pulling, and see what you are going to apply the equilibrium, it is pulling that particular joint. Therefore totally how many forces are there? 3 forces are acting, and all the 3 forces are acting away from the joint. All the 3 forces are acting away from the joint. Now using this particular one, somehow I am going to get this angle. The angle between these 2 forces is A, the angle between these 2 forces is B, and the angle between these 2 forces is C. Is that right? Then according to sine rule, force divided by the sine of the opposite angle is sine B is equal to force divided by sine of the opposite angle is equal to force divided by the sine of the opposite angle. Okay, we are going to use that particular equation, Lami's theorem. And if you know one of the force, and all these angles, you can get the value of the remaining 2 forces. That is the application of Lami's theorem only when 3 forces are acting. If 2 or more than 3 forces are acting, you can't apply this particular Lami's theorem. Is it right? Now, for which here you have applied some particular force. Say at one particular point you have applied how much force you have applied at one particular end? Say 50.461 force. Now that amount of the force is transmitted to this. Is the equilibrium? Yes, it is in equilibrium. Why? You can have illa. First in the force is that only 2 forces are acting. Is that right? Now you have applied the third force. Still, other break it remains standstill, means it is in equilibrium. Totally how many forces are there? This is one particular force. How much is this? This particular one. This is the second force which is pulling this particular joint of matter of this particular one, and this is the third force, is that nothing but the equilibrium what you have applied, and it is pulling in the downward direction. Totally how many forces? This is one force, this is the second force, and the third force. Now say you are going to apply some magnitude of force. Now it has not torn out. Break it is in a state of equilibrium. Now to apply this particular Lami's theorem and to check it experimentally, what we are going to do is we are going to mark this particular point. This is nothing but the point of concurrency where the line of action of 3 forces are meeting. One the east ringo, in the east ringo, in the equilibrium, it is actually meeting at this particular point. Now how to mark? See, either the image, now you can observe that this is the point. Correct? This is the point, right? And see, this is the line, the direction of this particular force. Correct? This is the direction of this particular force. Sarina? And this is the weight, the third force which is acting. How the image point this is the point of concurrency. This is the line which you are going to see. This is the line which you are going to see, and this is the weight or the equilibrium that will be acting purely in the downward direction. Is that right? How much weight we shall apply, we shall see. Okay. Now we have one force at P. P is equal to
50.61.
50.61 grams. ಅದು 101.02 and this one is 50.74 grams. Isn't it? Now, these are the two forces. P is found to be equal to 50.61, right? And this Q is found to be equal to 50.74. The angle between the two forces is 75 degrees. Okay, angle between the two forces is 75 degrees. Get the value of the resultant by constructing the parallelogram. Okay, fix all the notes. Scaling draw ಮಾಡಿ okay, to some scale you get the mathematical resultant by applying the parallel law. Madi on point length say 1 centimeter is equal to 50 units and get the resultant. Madi you consider this parallelogram. You consider the parallelogram. First you scale hakodi. Okay. Say 10 grams is equal to 1 unit at the body. 10 grams is equal to 1 unit. 1 unit is equal to 10 grams. That is in one particular direction. This is how much? 50.74 over 10 is 5.7. Correct? This will be equal to 5.7 units. Scalar mark ಮಾಡಿ. Correct? ಮಾಡಿಲ್ಲ? ಇದನ್ನ ಮಾರ್ಕ್ ಮಾಡಿ. ಎಷ್ಟು 1 unit represents 10 grams. Therefore 50.74 represents how much? 5.7 grams. ಹಾಕಿಲ್ಲ 5.7 units. Then you make an angle of 75 degrees. You make an angle of 75 degrees. Madi 75 degrees half biಟ್ಟು. This is here 50.61 grams. This angle is how much? 75 degrees half biಟ್ಟು. This is 5.6 units. 5.6 units. ಹಾಕಿದ್ರಾ? 5.6 units. Okay. ಮಾಡಿದ್ರಾ? Then you draw a line parallel to this for 5.7 units. You draw a line parallel to this of 5.6 units. Draw ಮಾಡಿ. You have considered a parallelogram. Now you join from tip to tail. This is the resultant. ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಿ ಟಿಪ್ ಟು ಟೇಲ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? ಎಷ್ಟು ಸೆಂಟಿಮೀಟರ್ ಬರುತ್ತೆ ಮಾಡಿ ಮಲ್ಟಿಪ್ಲೈ ಬೈ 10 ಮಾಡಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಷ್ಟು? 8.9. ಎಷ್ಟು ಬರುತ್ತೆ? ಇದು ಎಷ್ಟಾಗಿದೆ? 5.7. ಇದು 5.6 ಆಗಿಲ್ಲ? ಓಕೆ. ಆ್ಯಂಡ್ ಇಲ್ಲಿಂದ ಇದಕ್ಕೆ ಪ್ಯಾರಲ್ ಈಗ ಹೇಳಿದ್ರಾ? ಹೇಳಿದಿಲ್ಲ? ಪ್ಯಾರಲ್ ಹೇಳಿದ್ರೆ ಸುಮ್ಮನೆ ಹೇಳಿದ್ರು. ಪ್ಯಾರಲ್ ಹೇಳಿಲ್ಲ. ಈಗ ಏನೋ ಇದಕ್ಕೆ ಪ್ಯಾರಲ್ ಆಗಿ ಈಗ ಹೇಳಿದ್ರಾ? ಇವೆರಡು ಇದು ಮಾಡ್ಕೊಂಡು ಅಂತ you measure from here to here how much? ಎಷ್ಟು? equal to 8.9. See here we have applied the law of 101 point something. Okay. Now this is the equilibrium. Now the resultant of these two processes is how much? 8.9 ಅಂದರೆ 80.9 grams ಬಂತು. Now since R is existing, it is not in equilibrium. R ಬರೋದ್ರಿಂದ it is not in equilibrium. We are going to add the third force C, which is equivalent to this particular one is 80.9 apply ಮಾಡಿದಾಗ it is going to be in equilibrium. So the resultant ಬಂತು it is not equal to 0. Here ಮಾಡಿದ್ರೆ ಈ ಪಾಯಿಂಟ್ you apply the third force. Okay, this particular force of atom equal to the resultant. We are going to apply opposite in this particular direction. That in general we call it as equilibrium. Now here see what we have applied. The first force is this one, the second force is this one, and the third force is C. What we call it as equilibrium. How much you have applied? It is 80.9 grams you have applied. Now the system is in equilibrium. Correct? First equilibrium ಇರಲಿಲ್ಲ ಎರಡು ಫೋರ್ಸ್ ಇದ್ದಾಗ ರಿಸಲ್ಟೆಂಟ್ ಮಾಡಿದ್ವಿ. Then you apply a force equal to the magnitude of this particular one, which is acting in the opposite direction. That in general we call it as equilibrium. Then what's the sign rule? You know this angle. Okay, you measure this particular angle. It is draw ಮಾಡಿದ್ವಲ್ಲ. You measure ಈ angle measurement ಮಾಡ್ತೀವಿ, ಈ angle measurement ಮಾಡ್ತೀವಿ, ಈ angle measurement ಮಾಡಿದ್ರೆ then force you have the sign of the opposite angle between the other two. Force you have the sign of the opposite angle between the other two. Force you have the sign of the opposite angle between the other two. ಅಂದ್ರೆ one force ಎಲ್ಲ angle ಗೊತ್ತಿದ್ರೆ if you know one force and all the angles we can get the other two forces. That is application of this Lami's theorem. ಸರಿನಾ? ಓಕೆ, ಇದನ್ನು ಮಾಡಿದ್ವಿ. ದೆನ್ ಲಾಸ್ಟ್ ಒನ್ ಸಪೋರ್ಟ್ ಕರೀಲ್ದಾರ ಸೌಂಡಿಗೆ